Hello everyone, I am Abhishek and today we are going to solve coin change problem. So let's first understand the problem statement here first. So I will read out the question here. So you are given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money. Return the fewest number of coins that you need to make up the amount if that amount of money cannot be made up by any combination of coin return -1. So you may assume that you have a infinite number of each kind of coin. Okay, so in the question it is given that we have we have an array of coins like which has all the denominations of the coin like 1 2 and 5 which we can pick, and as it is written that we can assume that there are infinite number of each kind of coin, so we can pick any number of coin from the array. So one to make it 11 one we can pick 11 times to make it 11, or we can pick 5 times 2 and 1 time 1, so total 6 coin to make it 11, or we can pick 2 times 5 and which will make it 10 and 1 to make it 11. So the all the three possible scenarios that I told you, the 2 times 5 part and 1 time 1 part, total 3 coins turns out to be we are taking total 3 coins here. So 3 is the turns out to be the minimum value, so minimum number of coin that is taken. So that's what we need to find out in the question here. So let's jump straight into the solution here. So how I am trying to approach this solution. So I know that I can take multiple number of times this 1 2 and 5, whatever indexes, in the indexes the number I've given, I can take it multiple number of times. So one thing would be like here I can have uh, here I can add or use the peak don't peak pattern. So I will pick the index or pick this number if my amount is less than or equal to this number, so that I can pick it, and whenever I am picking it I need to decrease my amount value. And I can have one more case here that I don't want to pick this coin, and when I don't want to pick this coin I will just have my amount as it is, and I will go to the next index and check if I can pick and don't pick. And uh, like that I need to go to the end of the index, and when I reach end of the index and at that time if amount is 0, then I need to return my minimum value from that part. And if my amount is not 0, uh, and my index is like out of the index size, out of the range of the index, that is like 0 1 2 3. For this case it will be 3. Then I need to return some value that we should not consider, because we cannot return their -1 also, we cannot return 0 because we are considering the minimum cases. So we need to return int max to return the maximum index. So mm, let me start making a function where I can have my index traversal. So I will make a helper function where I will pass the coins and the amount and my index. Then from here I need to return the minimum value. So I will have this as int, then we are going to the coin and the int amount, and here int idx. So from index 0 I am starting here, and let me have the peak case as I told you. If my coins of index is less than is equal to amount, amount amount, then only I can go to the next recursive call. And in my next recursive call, I don't want to increase my index because I want to also consider 1 multiple times. So I'm not increasing the index, but I'm decreasing the amount as I have picked the coin. So coins of ID X. This sounds to be fine. Coins, yeah. Then this will be my take case, and I will go to my not take case also. So on my not take case, just I need to increase my index IDX plus 1, and then here I am going to make two variable which can store the value returned from this helper, and whichever will be the minimum one, or we can only have the take value. So take value will be int max. So why I have chose int max here, I want to not int max but int max minus 1 will be fine, and take case equals 1 plus, because I have taken one coin. See what I am doing here is, or we can take int max. Int max, okay, int max also will be fine, not int max minus 1. So what actually I am doing here is, like, first I am checking here that if I can take this option or not. So if I am going to take this option, then I am just whatever return from my sub problems, so I will add 1 plus to it, so that I have taken one coin. So that will be my take case. And why I have made it int max is, in some sub problem this condition might not be taken. So if I initialize this with 0 or 1, so my take condition will remain 0 and 1, and at the end I am going to return the minimum. So if I am going to return the minimum, so if I am going to return the minimum here, then then if I am going to return minimum and take case is 0 or minus 1, that value will be taken, because that is minimum. So that's why I need to initialize with some maximum value. And let's have our base case here. Base case will be if index is equals to coins dot size, then we need to return return int max minus 1. Why minus 1? Because if by any chance, okay, let me first correct my indentation, and if by any chance this helper function returns int max, then 1 plus int max will be out of bounds, so we cannot so that will give a runtime error to us. So that's why I am making our int max minus 1, so that if int max minus 1 is returned to here, 1 plus int max minus 1 will become int max. So the take which we have defined here as int will be like valid. And like if we want to return int max also, that also fine, but we need to define this as long int so that it can take the value of int max. And one more thing would be, if index is there, and one more thing, amount. If amount is equals to 0, then we need to return 0, so that we are considering that. But this part I want to be on the top, so that this condition is checked first, after that only this condition should be checked. So if in any case like we are out of bound but we have amount 0, that case also we have to consider that. So I am taking this part and I am returning it, and I think I will solve, but yeah, some thing. Okay, here int answer equals this, so return answer equals to int max minus 1, then it will be minus 1, else we just need to return minus 1. int max -1. So let's have our answer here. Yeah, so then we need to define our array. Coins dot size, and then vector of int amount +1 and -1. I'm going to initialize this with -1. I'm passing my dp here, and here also I need to pass my dp, and here also I need to pass the same dp. And in this case I will have this if my dp of index and the amount equals -1, then I need to return this thing, dp of index and -1 only. And before returning it, what I want to do here is I'm just going to add this to our answer, and I can sum it over here. I think everything are done correctly. Okay, some wrong answer we got here. Let me first check here if everything is done correctly. Amount this, if it's not equal to -1, then we are going to return our dp. Yeah, here we got our answer correct. And let's also do it for index from n to 0. So from n to 0 everything will be same, but this index, whenever it reaches less than 0, then we need to return this. And oh yeah, this all are correct. And this index, we are in the index, and we need to go to the previous index. And here we need to pass coins dot size -1, as we are going from n-1 to 0, so we need to pass the last index here. So let's first run it, then we will submit it. Yeah, so in this video I've completed the solution for 0 to n and n to 0 in recursive and memoization, that is the top down approach. And let's discuss the time complexity. The time complexity from 0 to n or n to 0, in the both cases, here the time complexity will be O of this coin size into the amount, and and time complexity will be O of coins dot size into amount. Yeah, that's it. And space complexity will be O of coins of size into the amount, and the auxiliary space that the stack which is created from this helper. So that would be how much I can consider many times one, and I can take the not take case also. So I can go through this all, and also I can go through one amount. So here the auxiliary stack space would be O of coin size plus the amount. Okay, so total time complexity is O of n into m, we can say, and total space complexity is O of n into m plus O of n plus m. And yeah, that brings to the end of this video, and thanks for watching my video.